Okay, so good afternoon, ladies and gentlemen. Let me introduce myself. My name is Jakub Masek, and I'm leading data squad in Moneta Money Bank in Czech Republic. And I am responsible for establishing a data lake in the company. And I have the honor to introduce you my co-speaker and my colleague, Milan Berka. Milan is from Datacentex, and Datacentex is our partner on our cloud journey. And I can say that Milan is a universal soldier because he is having a unique skills.
Thank you, Jakub.
And he is a professional machine learning engineer. He is a developer, and he is helping us. And I'm very glad to have him in my team. So if we can go to the next slide. Okay, so what's on the agenda today? I will briefly introduce our companies, and then I will guide you through our cloud journey from more of the business perspective. Then I will ask Milan, and he will introduce to you our platform infrastructure. Then I will explain you some of the use cases we are now working on, and then Milan will make a deep dive into one of the use cases we are working on, and he will show you all the technical things. And hopefully we have some time for Q&As. Okay, so briefly to introduce Moneta, if I can say it in one sentence, I would say that Moneta is a Czech bank for Czech people. We are having about 1 million customers. We are having 3,000 employees, about 650 ATMs all around the country, about 181 branches. And we are fourth biggest bank in the market, but we are number one in innovation, and we seek to be a digital leader in our markets. Okay, and almost forgot about Tom, our advertising star. If you live in Czech Republic and you will see our advertising, you will see that we are the bank with the cat. So just want to mention that. Okay, so then introducing our partner, Datacentex. It is a European data science center of the excellence based in the heart of Europe in Czech Republic. They are having branches in Prague and in Brno. It is a machine learning and data engineering boutique, and they are having more than 50 experts from with different skills, and they are ready to help for different industries. And Datacentex is actually having their stand here in Expo, so I think you are more than welcome to visit them over there. Okay, so what's our cloud journey about? If you want to be a digital leader, you need to be digital inside, you need to have digital DNA, and you have to do things that no one else is doing. And so that's why we decided to move our bank to the cloud. And so far we are having more than 30% of our applications based on cloud services, and the target for next year is to have more than 50% of them in the cloud. So hopefully we'll have an optimal cloud hosting by 2021. And when the whole bank is moving to the cloud, my task is to build the data lake, of course, in the cloud. And if you want to do things that no one else is doing, you have to explore new data, and you want to try new techniques, state-of-the-art machine learning algorithms. And with the previous analytical system, we just simply wouldn't be able to do it. So that's why we decided to go cloud. That's why we decided to use Databricks, and that's why we decided to use open source frameworks as Spark, as other languages as Python, R, and so far and so on. Okay, and and move on. So simply, we are actually building our data lake ecosystem, and we are pioneering the analytical world. When you say data lake in Moneta, we mean a couple of things. First, of course, it's about the data lake platform. And we are having the platform in the cloud, and we are using Amazon services. For the storage, we use the S3 service, and for the advanced analytics, we use Databricks. Data lake is, of course, about data, and banks are full of data, and if you go digital, you have even more volumes of data you have to explore. So we are using both internal and external data sources. that we are exploring. And data team is of course about the team. You need your data engineers, you need your data scientists, and we are having both. We are having our internal team, and we are actually buying experts from Datacentex, which is giving me flexibility, which is important for me. So, for example, when I want to start a new project and I need extra 2 data engineers, I can have them really quickly, and I can work with this on. And this flexibility is very important for me. Data lake is, of course, about the data science use cases that are actually driving our innovations. And through them, we are actually serving our internal customers, and we are showing the value that is hidden in the data. And data lake is for us, of course, about involving other teams when we are democratizing our data. So we are actually helping with onboarding other teams, and we are showing them how to use the new techniques. So now I would like to pass the microphone to Milan, and Milan will guide you through our platform infrastructure. So Milan, it's yours.
Okay, so thank you, Jakub, for introduction. So as we mentioned, the data squad role is to build the data lake platform in the cloud. And in Moneta, Moneta decided to use AWS as its main cloud provider. And so far, when they're migrating their on-prem solutions to the cloud, they are doing it in the most basic infrastructure as a service type of migration. So in their data center, on-prem, they have some virtual machines and something is running on them. And what they are doing is they are taking these virtual machines and just buying the cloud machines and migrating the software. Because Data Squad is really building it from the ground up, we decided that we will utilize the cloud services. So we will not do the infrastructure as a service way, but we will go with the platform or even like software as a service way. So the main goal when building the analytical platform is to utilize the cloud services as much as possible. So we have to decide what technology we want to use. So for storage, which is like the center of the platform, we opted for as AWS S3 as like no other option there. And then we have to choose some computational engine on top of the S3. And we decided to go with Databricks, because Databricks out of the box provides the most complete ecosystem environment which we could think of. And we knew that we want to tackle some big data, so Spark and Python is the way to go. Also, we experimented with AWS Glue and AWS EMR. I don't know if you guys are familiar with these services, but Databricks is definitely the most comfortable option. But we are utilizing the Glue and EMR as well, as we will see. Okay, so when we are building the platform, there is like a lot of security and compliance measures we have to deal with. And maybe I will talk about this later, but it took us like half a year just to get security compliant, and we are really proud of what we done with the platform. And here are some measures which we took just to ensure everything is secure and we won't have data breach. This is like high-level overview of how the platform actually looks. So on the left side, you have the old world. This is like the on-prem data center. And the old world scientists, as we like to call them, we don't want to bash them, but they're using SAS and Oracle. So this is slow. We have some limited resources on the Moneta side. The data warehouse is rather old, so there is a lot of like technical depth, and the performance is not where it could be. And also SAS is like weirdly interconnected. It's like some weird creature that is connected to a lot of internal services, and it's providing data to them. But it's not really that flexible. And we know that if we want to process big data, we can really go with this option, or we know there are better options. So basically, on the right side, you have our AWS environment. In Moneta, there's a lot of accounts in the AWS, and one of them is dedicated to us as a data squad. So this is basically the data squad or data lake AWS account. We have established AWS Direct Connect, which basically says this is one network. So I can see from this VPC from our account on the on-prem and vice versa. And then we establish some ETL jobs, and actually here is where we use Glue. So we are using Glue to extract data from on-prem world and pump it into the S3, which is right here. Okay, and on top of S3, we have the Databricks. And then what we are trying to do is always prototype the script or the Spark job in Databricks because it's more comfortable. And then we want to migrate it to Glue. So Amazon is then taking care of the ETL process. And between here, we have a Glue Metastore, which is basically storing, or this is the abstraction above the C3 files, which we can then query with Spark. Yeah, so this is just an example of how we thought about the data lake structure. I think it's rather common, like common picture. So we have actually two buckets in S3, and then we have folders, or let's call it folders because these are objects. And one of these is data, then we have sandbox, and we have solutions. So basically all the raw data is being pumped into this data folder, or data square, into landing folders, and then we are doing ETL process above them to get the parsed, which is basically like here in the landing, there are JSONs and XLs and CSVs. We are historizing them in the raw, and then we are parsing them into Parquet. And above Parquet, this is where the data analysts then do their analytics, which brings us to the solutions. So we have use cases, we will talk about them later. Basically, every use case is a solution which takes data from the data folder, process them, and then if the outcome is like reproduce or usable in some other projects, it can actually return the outcome back. Okay, so this is the infrastructure sum up. And now back to Jakub and the use cases.
Okay, so for the use cases are actually driving the innovations, and use cases are based on our data. And the better data you have, the better outputs you can await. So this is actually the reason why we are continuously building our feature lake or feature store, if you would like to, where we are actually concentrating our features that are extracted from our internal and external data, and are the key building blocks or ingredients for our use cases and for our models that we are delivering for our customers, for our internal customers in the company. And the customers are having different awaitings. Some of the customers are awaiting full end-to-end product, and some of them are awaiting just the highest or the high quality features that are using in their own models. So today I'd like to share some of the use cases with you, and I'll touch the digital story and the branch story. So if we can jump to next slide. So digital story. Digital story is about digital marketing and digital sales. We can say that the customer loan is a key product for our bank. It is a cash cow product, and if you look to a digital customer journey, you can define 4 different stages that are represented by the See, Think, Do, Care funnel. You can see on the slide. And in the C phase, there are customers without any particular need. Then in the think phase, there are customers that are having actually a particular need they are willing to buy some product. For example, if you look for a new kitchen or you want to reconstruct your house. And then there is the do phase where customers are having a need for a financial service. So they want to finance their need, but in another way than paying it in cash. And then you have the care stage, which is about customer experience and with some after-sales activities. And the assumption is that all the people are actually browsing the internet, so they are in the see phase, but only part of these people are then in the think phase when they are actually looking or searching for information about the product, the needs they want to buy, and part of these people are then in the do phase when they are thinking to finance the product with some financial services. And each of the stage is having a typical, let's say, media mix that is also represented on the slide. Actually, we are in Moneta. We are pretty good at the do stage, but if you want to grow, there is no potential. So what we see a relevant touch point gap and opportunity we would like to address. So we would like to move our activities from the do stage to the think phase. So we'd like to move to the upper layer of the customer journey funnel. And we are having already a plan in motion. So that actually the 4 action points. And the first one is we want to be sure that we are investing our marketing budget effectively. So the first case is about digital marketing cost analysis. Then the second one is about ad quality. So we want to be sure that we are buying the highest quality ads, so meaning the most visible ones. And the third and the fourth part is about targeting. So we want to be sure that we are actually addressing and targeting the right audience, and both in the digital and in traditional channels. So I'd like to share some of the results, because number 1 and number 2 we are having already in production. So I will be sharing some results with you. So regarding the cost analysis, actually what we did, we made an attribution model, and the attribution model is actually showing how your current spendings to the marketing channels are effective. So what were the data ingredients, the data we used? We used the advertising data, which are showing on which customers, on which page, and for how long has seen or interacted with your ad. Then we use, of course, the marketing costs, and we used the Moneta website behavior data. And we did a Markov model, and the result you can see in the table, where the marketing channels are compared to a reference ratio, which is represented by the performance search. So there is the value of 1. So you can see they are much more effective channels. So what we did, we actually reallocate, or we are continuously reallocating our budget from the performance search to the ad form, to real-time bidding, buying of the ads. So the business case here is that with the same media budget, you are able to drive and to increase your digital sales. The next use case is about the ad quality. We discovered that there is huge differences between the visible of the ads on the internet. So we use this metric in our quality model. And the quality model is actually then adjusting by multipliers the ad form. Ad form is the real-time bidding platform through which we are buying our ads. So the business case here is that with the same budget, we are able to buy 20% plus more visible time of the ads. Okay, next one. And the third case is about the branches. Because when you're moving to digital, there is also, of course, a potential to optimize the traditional channels, and one of them are the branches. So what we want to have is an independent evaluation of any location in Czech Republic in terms of its attractivity. So the assumption is that the locality attractiveness is given by points of interests that are surrounding the point you are. No, go back. So you one more back. Okay. So the locality attractiveness is given by the points of interest around it, and each of the point of interest is having its weight, and the total attractiveness is then given by sum of the partial weights. But the trick is how to set the weights. So we actually made a machine learning model, and for learning data, we use data from all of our branches and all surrounded points of interests. and we set the target value, which is actually the banking performance, we are now able to predict. So for any given location in Czech Republic, we are able to predict the possible banking performance. We are saying that it's a performance index. And in the next slide, you can see an example of an output. There is a map of the center of Prague, and the gray spots are showing the predicted performance index. The blue dots are showing localities with high performance index, and the purple pins are showing actually the locations of our current branches. So you can see that there is definitely potential for optimization. So we are now passing this tool to our colleagues who are responsible for branch planning, and they are taking into account these inputs. So they are working on this. So now maybe I'll again pass the microphone to Milan, and Milan will deep dive into one of the use cases and will technically explain how we are working.
Yeah. So basically we have a lot of use cases, and we are thinking like which one to show you. So if you want to see something else, then just reach out after the talk, and we can talk about the branch Spark code or the first one. But we opted for this. This is called DSID, as a data squad ID, and the problem we're trying to solve. We have many data sources which identifies our customer. So this is like the classical customer 360 problem. When you have online data, you have offline data, you have transactions, you have banner touch points, like who saw what on which page, and you have a lot of IDs, and you want to basically get something like one ID, one single ID that will define what the customer actually saw, what he did, and this is what the SID is all about. So the question is like how we connect all these IDs into a single ID, given we have some bridges, like when someone clicks on a banner, he gets on our website. So we have ad form ID, we have our website ID, and then if he logs into the banking system, internet banking, then we suddenly have his internal ID, and we can interconnect everything together. Yeah, so how to do it in Spark? So first, like, we can join everything together, and we can make this incredible big nice join, which will probably never finish running. But then we thought about, wait, so Spark has all these nice libraries, and one of them is graph frames. And I don't know if you guys heard of it or ever used it, but this is really cool library which is made for running graph operations or graph solutions on top of the Spark data frames. Yeah, so basically this is how our tables looks like. We have like these, let's say these three sources, and this is the bridges like between the IDs. So I have a website ID v1, and through some on the customer path, we are able to match this website ID on the internal ID. This is basically like I log into my internal banking, and I'm able to match my cookie from browser with the internal ID. And the same for ad-form ID or internal ID phone. This is like clear. Yeah, so basically first you just have to take care of the data quality inside of these. So for example, here we want to filter some fake phones. Obviously, fake phones won't appear in our main database, but we have form on website when someone can fill some crazy number, and we want to filter those. And then we want to prepare the data frame in a form that the graph frame is able to swallow. So this is just some basic renaming of the columns. And as you can see, we are already building something like edge. So source and destination, it's like edge in the graph. And then we just union everything together. And we have one big edge data frame. And then we just build the graph frame. So this is what we have. We just extract vertices because this is something that the graph frame library requires. So this is basically just distinct of all the nodes we saw on the first slide of this deep dive. And then we call connected components. And this is basically looking for, I don't know, yeah. So basically this is looking for these connections. Like this is one component. The line is representing one component. So basically this is where we connected all the IDs into one single entity. So this is the resulting data frame. And here we can see, okay, so V1, this is website ID1, is in the component 1. And the same is for V2. And suddenly, okay, so component 1 is these two web IDs and this internal ID and the platform ID and this platform ID 2. So this is basically what we call is one client of ours. And now, when we do have this, we are able to do the attribution modeling. Because without this, we are not really able to match, to catch the entire journey. So this is basically enabler for this particular task. Maybe good question is how long it actually takes to run, or what are the dimensions of the problem. And these are some numbers. So we have 30 million connections, edges on this number of unique vertices. And we are running this on cluster that is, if I recall correctly, it has like half terabyte of RAM and about 100 cores. It runs about 20 minutes. It takes about $4 to run this thing, and maybe we are able to even optimize it further. So, yeah, this is like how we solve this this painful issue of one ID across many systems using Spark. Okay. Yeah, so maybe, Jakub, you can wrap up this talk. Okay, yeah, so one question. How many people you think takes to make this possible, this entire platform, to build it up, to do the use cases, put it out, have a presentation on Spark Summit? So who thinks it's more than 10? Okay. So who thinks more than 5? And the rest is like, takes one to do it. It takes two of us. No, so actually it's 5.5. 3 guys of Moneta, really great, skilled data scientists, and Jakub, like the best project owner, and 2 others from Datacentex. It's like, if we should see the roles, it's like 3 data scientists, 1 project leader, which is enormously important, and we have 1.5 data engineers. Good.
Okay, so and just a brief summary. So even with a small team, you are able to do great things. So don't be shy. And to achieve this, you need to have strong partners. And for us, it's Amazon, it's Databricks, and Datacentex. And be disruptive and be hungry for the data and show that data is really the new oil for your company. Safety always first. So it is extremely important, even when working with data that and GDPR, all the things with the GDPR. And don't forget that data science is about data and the science. And when you do science, sometimes you can be linked to some dead ends. So be patient and keep going. So that's all for us. So if you have any questions.
Questions?
How different is your on-prem solution?
Yeah, hi. Thank you for a nice presentation. How different is your on-prem solution in terms of business value, and what type of analysis have you added to through the new solution which were not present in the old one?
So what was the difference between the old and the new?
The
world?
on-prem solution, I saw a slide with the old data warehouse.
Yeah,
I
so
assume
maybe
you
it's
had
for Milan.
Yeah, so to me, like, one big point is the difference is the data, actually, because in our solution we are basically the main capturing point of all, even online data, of all online data is basically stored in our data lake. And on-prem is not really able to like process all these quantums of data as of now. So basically the on-prem world is confined to either the transactions, the data from internal systems, and then they are using the data lake as a pre-chewer or preprocessor aggregator of the online data, which are then used in the on-prem systems. Yeah, and also one issue is that the on-prem guys don't really have access to like the state-of-art. Yeah, so when they want to do neural networks, when they want to try it, they basically don't have really a weapon tool to make it real. So these are, to me, like big differences. Also, is the rigidness of the solution, because when they want to do some new data mart, they go to the BI chef and he is like, okay, so that's 10 man days, and they're what? No, so it's maybe 100 man days. So this is the difference.
I think I saw that you're using Adobe Marketing Cloud in one of the.
Yeah, as for the data source, Adobe we are using for the Moneta website data, so we are actually having this data source.
Because I think that Adobe has the solution to handling single ID for customers. So my question is, why don't you use it by Adobe? Why do you utilize Spark instead?
Yeah, but we need to actually connect this to our current customers, so they are not able to do this. So that's why we are building this.
Basically, the next point is that we want to have this under control, at least on some level, and at the same time, Adobe Analytics. I'm not sure about the security measures there. I think there was some problem with its security on the level of the Adobe.
Hi, thanks for the presentation. How big is the scale that you have, and how many users you have for the data lake platform and the Oracle warehouse, which is already existing?
Yeah, so the question is how much users are using the data lake platform and how much are using the Oracle? Yeah, so the data lake, it's Data Squad is obviously using data lake, and we have two other squads. It's a risk squad, and then it's a CVM or CRM squad, and both has like 10 people. So it's, I don't know, 25, 30 people in total.
Hi. When you're building your single customer view, how did you distinguish customers that were sharing IDs, so people at the same address with similar phone number, same phone numbers, things like that? How do you distinguish the different people?
I'm sorry, I don't hear the question right, but I assume that you have family and they are logging into the same PC and they share the same cookie ID on the internet.
Yeah, so just
And
sort of shared IDs.
Yeah. So basically there's one extra mechanism. I'm not sure if we have time to actually go deeper. Maybe we can take this offline. But what we are doing, that we are actually taking the internal ID out of the picture. We are interconnecting all the other IDs, and then we are just pinning the internal IDs inside. And we basically said that we don't want two internal IDs to have the same DS ID. So this is some level of isolation, and basically, as a next step, we want to have like probability of this DS ID belongs to this ID. We basically want to have, okay, so maybe in December this DS ID was this internal ID. At June this DS ID is maybe different internal ID because we have more evidence that it's so.
All right, thank you very much. Very good presentation. One question is, what kind of attribution model did you use?
Yeah, it's a good question. So we used Markov Markov attribution model, which was actually coded from scratch in Spark. I'm not one who implemented it, but we have an expert here. So if you are interested in more detail, then we can actually discuss it offline. What is the Markov model?
You mentioned the costs of, if I remember well, 0.5 terabyte of RAM. And what was that again?
What was what?
The cost.
The cost was like $4.
Who is your provider?
Yeah, it's AWS and Databricks, of course.
Hello, thank you for the presentation. Just one question about the deployment to production. Once you experiment your model in Spark, how did you deploy it as an API or?
Yeah, so this is a great question. This is something we are currently, we are in phase when we are deploying the models into production, or we are going to do it. So we don't have the framework as of now, or the tools, but we are actually thinking about it. And the first deployment of some model will be in January, I guess. And we are building AWS API gateway driven API. Not SageMaker. No.
All right. Any other questions? Okay. All right. Thanks guys for the presentation.